All right, so here's another example of algebra of functions. So here we're going to have, we have f, which is x plus 5, and its domain, since this is a polynomial, is all real numbers. This is a rational function, so its domain is all real numbers except where the denominator is equal to 0, and the denominator is equal to 0 at x plus 4. Or, yeah, the denominator is x plus 4, so when I choose x equals minus 4, we get a division by 0, which is bad. So this is our domain. All right, I was just interrupted. I paused it, and now I have no idea what I was talking about. Okay, so I think I was talking about x plus 4 is the denominator. When x is equal to minus 4, we divide by 0, which is bad. Okay, so now we're going to look at finding f plus g. And so what we do is we take x plus 5 plus 3x over x plus 4. And we're going to simplify that on the next screen. Let's talk about what the domain is going to be. So I can put any number in here, but I can't do that here. So the domain, I have to take out all the numbers I can't use here and all the numbers I can't use here. So we just have minus 4 that we can't use. So my domain is minus infinity to minus 4, union of minus 4 to infinity. So that's going to be my domain for the first three, f plus g, g minus f, and f times g. Okay, so now let's simplify our f plus g. So this is just like a fraction, because this is a rational function. So in order to add these, I need a common denominator. So this has a denominator 1. So to make it common, I just need to multiply on top and bottom by x plus 4. So that gives me x plus 4 on the bottom, and then x plus 4 times x plus 5 on top, plus 3x. So at that point, I can take all of this over the common denominator. All right, and so now what's going to happen is I'm going to distribute here, because I need to combine like terms. So first I start by expanding. So I get x squared plus 5x. And now I'm going to expand here, so I get plus 4x plus 20. So that takes care of this term, and then plus 3x. And that's still all over x plus 4. So I have one x squared term. I have 5 plus 4 is 9, plus 3 more is 12. So I have 12x plus 20, and it's all over x plus 4. And my domain we already talked about on the last screen is minus infinity up to minus 4 to infinity. Now let's take a look at this, because on the next screen we're going to talk about g minus f. So these are going to change places, but all that's really going to happen is this is going to be a plus and this is going to become minus. So g minus f of x. So I have 3x over x plus 4 minus x plus 5. That's over 1. So again, I need a common denominator, and we already found that when we were doing it on the last slide. So I'll do a little bit, we multiply this by x plus 4 over x plus 4. So we get 3x minus, so I expand just like I did on the last screen, x squared plus 5x plus 4x plus 20, but we need to keep it in parentheses and distribute the negative. This is going to combine to 9x, so when I do this, I get 3x minus x squared minus 9x minus 20. And so I get minus x squared, minus 9 plus 3 is minus 6. So minus 6x minus 20 all over x plus 4. And my domain is exactly the same as it was for the last one, minus infinity to minus 4 to positive infinity. All right, the next one we're going to do is f times g. So that's going to be x plus 5 times 3x over x plus 4. And we multiply just like fractions. Since this is x plus 5, I can rewrite it as x plus 5 over 1, and then I multiply across the top. And I multiply across the bottom. Of course, it's times 1. So I just get x plus 4. So I get 3x squared plus 15x over x plus 4. That's it. And then my domain, I've already found, so I don't have to think about it again. Just keep using the same one. And so there's my f times g and my domain. The next one is f divided by g. Now the domain is going to be different here. Talk about that in a minute. Let's find f divided by g. So we get f, which is x plus 5, divided by 3x over x minus 4. Now, let's talk about domain first. Domain. I already can't use minus 4. But now, I also can't use, so this is not the final limit. So, I can't use minus 4, and I also can't let g of x equal 0. So here's g of x. And when is that equal to 0? So if I multiply both sides, so I have to solve this, x plus 4 on both sides, cancels over there, and I get 3x equals 0. Divide by 3, and I get x equals 0. And you might have been able to tell that. If this is 0, then the whole thing's 0. Anyway, so when x is equal to 0, g of x is equal to 0, and then f divided by g is f over 0, which I don't want. So my domain becomes, it can't be 4, x can't be minus 4, and x cannot be 0. So my domain is minus infinity up to minus 4 to 0, 0 to infinity. And now we need to simplify our expression. X plus 5 over 3x divided by x plus 4. So just like fractions, we're going to take the top and multiply by the reciprocal of the bottom. So this flips. 3x goes on bottom. And so this is 3x. And now we get x squared. So think about the last page. We get x squared plus 9x plus 20, and it's divided by 3x. And so now it's easy to see if x is equal to 0, then we're going to divide by 0. So anyway, that's my f divided by g, and that's my domain. This whole thing's my domain. Let's go ahead and talk about, I didn't write it on the front page, but let's talk about G divided by F. So what's its domain going to be? So we already have this domain. X can't be minus 4. That's from the last slide. But now we need to add f of x can't equal 0. So f of x is x plus 5. So if x is equal to minus 5, then we get division by 0. So our domain for G over F becomes minus infinity up to minus 5, minus 5 to minus 4, minus 4 to infinity. And then to actually calculate F over G, keep in mind that x plus 5 is really x plus 5 over 1, so we take the top fraction and multiply by the reciprocal of the bottom. And we get 3x over x squared plus 9x plus 20 because we've expanded x plus 4 times x plus 5 several times now. Notice that it is the reciprocal, the exact reciprocal of G over F. So F over G and G over F, they're reciprocals of each other. But their domains are different because what's on the bottom dividing possible division by 0 is different.